I'm back. All right, sorry about that. The cockatoo just flew out of the barn here. Okay, so we're talking about this guy here. So the calculator gave us this number, but 90% confidence has been used so long in statistics, and it's one of the most common, and before calculators came around, this was the best people could do. So you're gonna see that when somebody talks about 90% confidence, it's normally gonna be with a 1.65 or a negative 1.65. Okay, it's not going to use this guy here. So we wanna get into the habit. Not that this is wrong. If you were to do this in your homework or on a test or something like that, there's nothing wrong with it, but we wanna get in the habit on this one guy that we write it as 1.65. Okay, it just kind of keeps everybody, all people that have ever taken statistics know that 90% confidence is 1.65. Okay. All right, so we'll go with that. So that then becomes our z sub alpha over 2. And we don't even need the plus or minus sign on it, we just need the 1.65 because the minus and the plus are taken care of in the problem. So the z sub alpha over 2 is just the z-score that you get when you find this tail. Okay. So with that then, we are actually ready for an example. So let's see. I know we just did this, but I'm going to erase it so I can leave the formula up there and write the example below here. I at least want you to see the formula as we're doing this one here. Okay, so this one says, find a 99% confidence interval for the true mean weight of sulcata tortoises if a sample of 34 tortoises weigh a mean 163 pounds, and we can say the standard deviation is 13.7. So one of the things I really like about confidence intervals is that the problem has to ask you to find a confidence interval. In the problem it says find a 99% confidence interval for the mean. It tells you what variable you're looking at, it tells you your confidence, it tells you everything. So there's no like looking at this going, I don't know what to do. It tells you what to do. So it's telling you flat out, look at the confidence interval formula. Now, the next thing we do as we look down is we notice that we're talking about sulcata tortoises, which are the third largest tortoise in the world, big guys. And we're looking at a sample of 34. Now, the reason we want that sample of 34 is because it's large enough to assume normal, right? So that gives us normal. So we are good to go on this problem. Then it gives us a mean, and it gives us a standard deviation. So we have the numbers we need to plug in. Now, the other issue is this 99% confidence, and that's going to tell us about our z-score. But I just had you do one that was 90% confident, so this is 99, so this is going to be different than the last one. So we need to draw ourselves a little graph again. And remember that the idea is that we've got this middle part is where that confidence is. So this is 0.99. But remember, the little divided by 2 says, wait a minute, we only care about what's happening on 1/2. So we take the 0.99 divided by 2, which will be 0.495, right? And then we don't even want the 495, we want the complement over here. So the complement there would be 0.005, right, to get us up to 1/2 or 0.5. So we're going to go inverse norm, 0.005, and when we do that, we will see what pops out. Hopefully you got 2.58. So that's our z sub alpha over 2, 2.58. Now, we've already done a lot of work, but we haven't even really started the problem, okay? So now we are ready to find our confidence interval. So let's go ahead with the setup. Now I want you to pay attention to this setup because I have a very particular way that I want you to do this, okay? So this says, oh wait, I wrote the problem over. So here we've got our problem. So let's start setting things up in our formula here. So the first thing we need is our x bar. And that's going to be this guy, right? So we're going to start with the 163 minus our z-score, which we just took a couple minutes to find there, 2.58, times sigma is our standard deviation of 13.7 over the square root of n, which is 34, is less than mu, which is less than, so again, we're hoping the mean is in the middle here, 163 plus 2.58 times 13.7 over the square root of n. Now, ran myself out of space there, but got it. Now, I always want you to do this as a two-step process, okay? A two-step process. The first step is to find that margin of error. So the first thing you're going to do in your calculator is plug in just this bit. So we're going to have 163 minus, and then we're going to put something here. And then on this side, we're going to have 163 plus, and you're going to put, and it's going to be the same thing on both sides, right? But you're going to find that bit first. So we're going to have a calculator. Okay, so we're just going to go 2.58 times 13.7 divided by square root of 34. Boop. And I got 6.06. And remember, always carry a decimal unless it comes out perfect, but it's almost never going to come out perfect. So always carry some decimal places there. But now we've got the margin of error. So we have that margin of error. So plus or minus 6.06. Now that's the first step. Second step is to do the subtraction and do the addition. Okay, so subtract on the low end, 163 minus. So that one gives me 156 point, we'll go 94. And if we add it up here, we'll have 169.06. Does that look good to everybody, calculating wise? All right, so we've got our first step and then our second step. Now, like I said, we're at the point where we're now giving this to the public. And if you were to just say that, give that to the public, that means nothing to anybody. So now is the time where we have to start writing out our answers. So at the end here, the last thing you have to do is write out a complete sentence. And if you follow the format will always be the same for every sentence, okay? So if you just follow the same format, you'll never be in trouble. So the first thing you want to do is say that how confident you are and what you studied. So we can say, we are 99% confident the true mean weight of sulcatas is, and then we're going to write this out, but we're going to write it out in words, is between 156.94 pounds and 169.06 pounds. Okay. So we say how confident we are, what we studied. We're studying the mean weight of sulcata tortoises, and we tell what the interval is. So we're 99% confident the true mean weight of sulcatas is between 156.94 pounds and 169.06 pounds. Okay. Look good there. So we did our first confidence interval. And see, even though the formula, when we wrote it down, was super ugly, calculating it out really was not that bad, was it? Okay. All right, so let's look at another one. Okay, so this one, it says, find a 95% confidence interval. And I hope it's okay if we abbreviate confidence interval as a CI. You will notice that that's kind of the norm if you look in the book or even in the calculator, they use CI. So find a 95% confidence interval for the true mean, I'm studying this time spent gardening per week if a sample of 40 weeks shows a mean (72.6 minutes gardening. Okay. The standard deviation is 10.7 minutes. Okay. So we got, again, very similar setup here, very similar setup. Obviously a different example, 95% confidence interval, it's telling you what we need to find. Now, we did a 99% confidence interval and we got a z-score of 2.58, but this time they're asking us for a 95% confidence interval. So is it gonna have its own special z-score? It is. And since we haven't done this one before, we gotta do it. So again, the idea of the setup is that you draw a little graph like this. This whole area is 0.95, but we only want half of it, so we're going to divide it by 2, which means each side will be 0.475. But again, that is not what we are interested in. We want this guy out here. So if that is 0.475, this will be 0.025 using the complement there. All right, and then that's what we're gonna stick into our calculator with our inverse norm. So we're gonna go inverse norm 0.025, which should give us a z sub alpha over 2 equal to, and what did you get when you plug that into your calculator? Hopefully you got 1.96. Now, as I said, these confidences, they do change from problem to problem, but these are common, 90%, 95%, 99%. So the next time you do a 95% confidence interval, if you can remember that the z-score is 1.96, do you have to go through that whole process again? Because these get used so often, you'll get to the point where, you know, someone says to you 95 and you go, oh, 1.96. They say 99 and you go, oh, 2.58. They're that common. Okay, that's where the 90% confidence interval, you go 1.65. That's what it's been for decades. Okay? All right, so let's plug in and see what we can do here. so we got our formula again. So we're going to start with our mean, which was 72.6. Subtract our new z-score that we found, 1.96. And then we're supposed to go sigma over the square root of n, so 10.7 over the square root of, now we forgot to talk about this, is our sample large enough to assume normal? We're looking at 40, so yes, we are good to go. But we always need to watch that. I got forgetful. Now remember, the upper side is just going to be the same, but with a plus. So remember, two-step process, always. I'm going to be looking for both steps, okay? So when you do these problems, I'm looking for both steps and your sentence, both steps and a sentence. That's always what this should look like. Okay, so if you fiddle that guy away in your calculator, you should get like 3.32. Hopefully that sounds good to everybody. All right, so there's the first step. Then we do the addition and the subtraction. So we'll go 72.6 minus 3.32. So this side I get 69.28 and 72.6 plus 3.32. Over here I get 75.92. Hopefully that sounds good to everybody. Look good? Okay, so I see the two steps, and then the last step though is the sentence. So again, following the same format as last time, we say this time we are 95% confident the true mean gardening time per week is between 69.28 minutes and 75.92 minutes. So as long as you get into that habit, then you should never have trouble writing your sentence. You just follow that same format, plug in the different words for the different things you're studying and the different numbers, and bing, there's your sentence. But this is important because if somebody really was interested in the mean time spent in the garden, now they can read that. They don't see this and go, what the hell are you talking about with the mu and the little alligator signs? I don't know what that means. They look at this and they go, oh, okay. So now I know how much time is spent in the garden per week. Okay. All right. Now, before we are done, we've got one more thing we need to do. Sometimes, again, we're at the point where we're actually like in real life doing studies for people and giving this answer to someone, saying, here, this is what we got. And sometimes when we do that, if we're starting out a problem, they actually haven't told us how large a sample they're using, or if they have a sample ready or not. So now that we're at this point, sometimes we need to figure out how large a sample do we need. So the last thing in this section is called finding sample size. So the idea is that if somebody came to you and said, hey, I want you to study gardening time per week. Okay, go out and I need to know what the exact gardening time is per week. And you go, oh, okay. Well, no way that you're going to be able to ever collect a population, because every week there's another week, and there's just, it's going to be a mess to find the actual answer, and maybe even impossible. So you go, wait a minute, let me look at the past couple weeks. And you go, but how many weeks should I look at? How many weeks should I sample? Well, here's what you do, okay? So when you're setting up a problem and it asks you to find the sample size, the formula you look at looks like this. N equals Z sub alpha over 2 times sigma over E squared. Now remember, E stood for that margin of error, and it's just easier to write E than to write margin of error here. So E is the margin of error, but this is what you need. All right, so let me do an example here and show you what this might look like if someone was to give you this problem. It says, looks like this. How many people should we sample to be 90% confident of their mean salary? We want to be within $1,000, and the standard deviation is known to be 4,275. All right, so apparently you're studying the salary of people, okay? So someone is asking you to find the mean salary, and you go, oh, I can't find it. It doesn't even, not even specific, so does it mean every working person in the world? My Lord, that's a huge population. So obviously we're gonna use a sample, okay? We're gonna use a sample, but they haven't told you how many people they're looking at or anything. So they tell you though that they want you to be within $1,000. So when you give them that interval, they want the interval to be pretty tight. They're giving you what error they're allowing. So we need to know how many people do we need to study so that we can give a good enough interval that's 90% confident within $1,000. Okay, so we're gonna set this up. All right. Now, as we look at our formula, we notice the first thing in our formula is the z-score. And remember that the z-score we get from the 90% confident, yes? And if you think back a couple minutes ago, we actually did this one already, right? So the z-score that goes with 90% confident, wasn't that the first one we did that was a little bit weird, and we said that we always write it as 1.65? Well, that's it. I don't need to calculate it again. I've already calculated it once. It's not changing, okay? It's always gonna stay the same. So we're good to go with that. So as soon as you have them memorized, you're like, I don't need to do that again. Okay, so we're gonna start with n equals, we'll go 1.65 times the standard deviation, which is 4,275, and then divided by E. Now, E is that margin of error, so that tells us the within. They're allowing us to be within $1,000, give us a leeway. So we'll divide by $1,000. And then the last thing we will do is square the whole mess. Do not forget to square. When it comes to formulas, this is one of our easier ones, but the number of people that forget to square is so insane. You can't believe it. So make sure you always square your answer. Okay. So I got 49.8. But now remember, we're finding n, okay? So n I got as 49.8, but n is the number of people. So there's a decimal. Does that mean that I can just talk to 0.8 of a person, so like everything but their arm? If I'm talking to any decimal of a person, I got to talk to the whole person, right? So 49.8 isn't good enough. Whenever you're doing one of these sample size, guys, you're always going to round up, always. So we're going to look at a sample of 50. Okay? So we need to study or sample 50 people. Now, just as a little example, let's say that it had come out as 37.1. Can I round that down to 37? Or do I need that 0.1 of a person? Okay, this is the actual number. So we need that 0.1 of a person. Now you're not just gonna talk to someone's foot. If you're gonna talk to their foot, you're essentially talking to the whole person. So even this guy is gonna round up and this guy would go to 38. Okay, so keep that in mind that we don't ever, n is always a whole number, so we don't ever want a decimal on it. And we always want to round up, never down, up. All right, so this was our first introduction to confidence intervals. Not so bad, hopefully, and then finding the sample size. So then as we move on from here, we're just gonna introduce a couple more formulas. And then the trickiest part about confidence intervals is deciding when to use which formula, but the formulas themselves are not that bad. Okie dokie, I'll see you next time.